Hi, this is an introduction to map making in R workshop. So this video is just going to be an introduction to this workshop, which I've taught at a conference before and in a class. And then it's going to give an overview of the four different modules within this workshop and kind of generally what's going on. So this is a tutorial or module that assumes you have a basic understanding of R, coding skills, and some familiarity with geographic information systems or GIS. That does not mean you are familiar with ArcGIS. That is just one program to use GIS, but it just assumes you have some familiarity with what like spatial data are, what projections are, etc. And if you are unfamiliar with R, or would like a refresher, please visit the tutorials on my website. The other ones that go over dplyr, data wrangling, data visualization, and intro to R and R Markdown, which is this format. So, as a note for all of my documents I use in these tutorials, this is an R Markdown document. Therefore, all text outside of code chunks is just text. So all of these paragraphs are literally just text, none of it is code. Code is only provided in the code chunks, and you can only run code that is written in the code chunks. And if you want to learn more about this documentation type, check out the R Markdown tutorial to better understand it. So these code chunks look like this. They're different colors. This is all code filling in libraries here. Okay. Now to start off this module, it's an introduction to how to use spatial data to make maps in R. And it is just an introduction to go over the different types of spatial data, how to wrangle them, and how to make static as well as interactive maps. It's just the basics of those things. So there's a lot more you can do with both of them. There are many ways to interact with spatial data and make maps, but we're only going to focus on a couple methods in this workshop series. And these methods use straightforward code that builds off of each other with consecutive lines to create a final project. And if you are familiar with ggplot for visualization or the tidyverse in general, like the dplyr package, it's very similar to using the pipe or the plus signs in ggplot, so it reads very similarly. I want to state the benefits of using R for spatial analysis and map making is that R is open source and free. The code is repeatable, so you don't have to remember what buttons you clicked on in like ArcMap or anything like that. And it's highly versatile, so you can basically customize your maps, visualizations, your analyses any way you want. And R can also be better and faster at doing some spatial analyses than things like QGIS or ArcMap. Minimally, instead of taking like 2 hours to load a very large data set, it might only take like 10 minutes. I've had a lot of issues with the ArcMap where it just cannot load the data quickly. It has literally taken 2 hours before because I just have really large spatial data sets. But in R, when you load them in, it's much faster. There's also a variety of things you can do with R and the spatial data, but this module again is just some of the most basic data steps in R to gain the familiarity and to give you the foundation to look more into the spatial analyses, especially since we're not covering that, as well as what more arguments you can add to make your maps look how you want them to do. If you are further interested in geospatial analysis or want more of a refresher, more of a foundation, I suggest looking at Dr. Emily Birchfield's tutorials, which can be found on her website here. Her tutorials are older, around 2018. I'm not sure if she's updated them, but they provide a good foundation in some analyses, especially, and things like projections and whatnot. While GIS and R is a very rapidly growing field, and a lot has changed in the past 7 years since these tutorials were made. There's still a really great foundation. And we just keep in mind that some things may have changed, like some packages and whatnot too. So the outline of this workshop is that we're going to use three types of data. These are the most common data files you are going to have that are spatial, including CSVs, the comma delimited files that contain longitude and latitude, shape files that are already in a spatial format, that's like .shp files, as well as rasters, which are typically in a .tiff file. And we're going to use these to create maps throughout the tutorial. The rasters in particular, my computer doesn't have great capability to work with rasters. They take a lot more RAM. So I'm just going to show some things with the rasters, and we're not going to focus on that as much. We're mostly focusing on the CSVs and shapefiles for this. So here is a basic roadmap for this workshop. One is how to import and export spatial data types, like converting CSVs to spatial point data, like shapefiles, cropping spatial data, and reprojecting data. Two, how to wrangle and manage spatial data to prepare it for figures using tidyverse functions. Three, how to create static maps using the tmap package. And four, how to create interactive maps using the leaflet package. The data we're going to use for these modules is multiple data sets. These are the data sets for the modules as well as the accompanying exercises. So each module, or this entire workshop, consists of 4 different modules. These 4 right here. And each of those modules has an accompanying exercises, which I also have the answers for that are uploaded or will be uploaded at least. And these cover a variety of ecological and demographic information in these data sets. So the first one is the fish community from the long-term resource monitoring element of the Upper Mississippi River Restoration Program. If you worked through the dplyr data visualization workshop modules, that is the same data set we used in that one. There's also this aquatic vegetation data set, which is through the same program, the LTRM, but it's vegetation instead of fish. We have the US states and territories, which are basically just outlines of the different states and territories of the United States. We have the United States cities, which is from the maps package in R. We have the world map, which is from the tmap package in R. We have this crops raster, which contains crop data for the United States. It's from the USDA. We have this river and streams data set, which is a shapefile of linear rivers and streams in the United States. And then we have the Upper Mississippi River pools, which are just polygons of 6 pools, the Upper Mississippi River system. These are 6 pools that are associated with this fish community and aquatic vegetation data set. So, all right, that's it for the introduction, and next module is going to get into the first part of this.